Alright, so a quick video for those that need a little refresher. We went over inverse trig. So regular, we normally say sine x equals y, or sine theta, or whatever it is. The inverse would be sine to the negative 1 y equals x. Or we could say arc sine y equals x. So the first thing we did is we set up all the relationships of pi over 4 with sine. So sine of 0 pi over 4, 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, etc. And its resulting ratio. And so now I have my input of, say, pi over 4 and the output of square root of 2 over 2. So if I were to turn around and say, well, what is the theta when the sine of theta is root 2 over 2 in between the restrictions of 0 to 2 pi, I know that at both pi over 4 and at 3 pi over 4, the ratio is root 2 over 2. So likewise, if the sine, or the arc sine of negative 1, that only happens at 3 pi over 2. Because as we're going along the unit circle, pi over 4 is right here, 2 pi over 4, 3 pi over 4, 4 pi, 5 pi, 6 pi, 7 pi, and 8 pi over 4. Now if I know that root 2 over 2 is here, remember the y value is the sine. So if I were to go right across, we have another y value right here. So at this x value and at that x value, they have the same y output. And so when we look at the thetas, that's the pi over 4 and the 3 pi over 4. If I wanted negative root 2 over 2, it would be at these two values that I would find those. So then we continued and talked about what if we had the arc cosine of negative 1/2 from 0 to 2 pi. Well, if I plug it in my calculator, I get 2.094, which is great. However, when I look at the unit circle, I can see that at negative 1/2, I'm actually going to have two values up here and down here. So the 2.094 is the 2 pi over 3, but also down here I have 4 pi over 3, which is 4.189 with the calculator. That also gives me the value of negative 1/2. Now just a side note, since it's negative, all the x values in the unit circle are the cosine values. So where it's negative would be on that side of the unit circle. So in quadrants 2 and 3. Next up we did sine to the negative 1 of 7/10 with a calculator getting 0.775. And so I know this mark here, but so the y value would have to be the same across the top, so I have to know what is this angle measurement. Now I know that these two angles are congruent, and I know that I want to go from here to here. Now from here to here is pi, so if I were to take pi and subtract the angle measurement that I know I don't want, I should be left over with what I do want. So pi minus the arc sine of 7/10 is pi minus 775 thousandths, which is 2 and 366 thousandths. So the answers are 0.775 and 2.366. Lastly, we went over the arctan of negative root 3 with a calculator. I know it's negative 1.047. And I had this from negative pi to pi. So I'm going from negative pi to pi. So that's the area I'm looking at. Now when it comes to tangent, since I want a negative value, quadrant 1 is going to be a positive over a positive, so that's going to be a positive ratio. I want a negative. This is negative over negative, so it can't be quadrants 1 or 3. The answers have to be found in quadrants 2 and 4. So 2 pi over 3 would be good, and 5 pi over 3 would also be good. However, it's outside of that interval range, so I'm going to subtract to get into the negatives, and I get negative pi over 3. And again, I knew it was pi over 3 because the ratio of tangent is y over x. And the y value being root 3 and the x value being 1, it would have to be square root of 3, 1, 2 as the perfect right triangle. And then we did the composition of trig functions. So if I had an algebraic expression, sine of the arc cosine of x. So the first thing I did is I went into the cosine and said, all right, so if you're saying it's x or x over 1, I can set up a right triangle and solve for y. Now sine is y over r. I now have my y value, I have my r value of 1, so I can conclude that the sine of the arc cosine of x is root 1 minus x squared. Now if I do a value that's a little more concrete, like 7/11, x is 7, r is 11, set up a right triangle, I get that y is 6 square root 2. So 6 square root 2 over my known r value of 11 gives me 6 root 2 over 11. Hope this helps.